point of inflection graphs. So this is what a point of inflection graph looks like. It is our most basic cubic. It comes in this form. The thing is, the transformations, for this are just like the transformations for a quadratic. So we know for the reflection of a quadratic, that's when we have y equals negative x squared, and that turns us from a smile graph to a frown graph, because it flips him. So for a cubic, having a negative x cubed does the same. We all of a sudden have a flipped graph, and that's how easy reflections are. Dilations, same sort of thing as with our quadratics. If I have y 2x cubed, that is going to make him into a fatter graph. So dilation, just whether it gets fatter or thinner. And these things are all listed on the front of your cheat sheet, so you can get those information as well. Translations, once again, same as with our turning point. If I have y equals x plus 2 cubed, that bit there is what tells me I have moved, in this case, I have moved left 2 units. Remember, positive is left, negative is right, which feels really wrong, but that's what it is. So I have just turned my graph into that. And if I had y equals x cubed minus 9, that just means I've moved my original graph down. So it's got a new point of inflection. That's what this is called, by the way. That is called a point of inflection. We tend to write it as POI for short. So then, let's look at one transformation where we've done everything. So y equals x minus 1 cubed plus 2. So that tells me I've moved 1 unit to the right, 2 units up, so I'm about here. And that's my new graph. So because of that, we can graph point of inflection graphs really easily. We just need to figure out the point of inflection and then any y or x intercepts. So these are the things we need. We need our point of inflection, which we can pull from here. This tells us how far we've moved left or right, how far we've moved up or down. So that would be my point of inflection. And we also want to find our y-intercept and our x-intercept. They're the most important things. So here, we're going to graph this one. Start with our transformations. Well, we have translated 1 unit right and translated 5 units up. Okay, so that's our transformations. So then to graph it, well, I need my point of inflection, which I get straight from the graph, 1, 5. Then I can get my y-intercept to when x equals 0. So that's nice and easy. We just sub in x is 0. So then we've got 1 cubed, which is negative 1. Negative 1 plus 5 is 4. So there's my y-intercept. Then if I can, I also want to get the x-intercepts. So we just rearrange the equation rather than having to expand and solve. So 0 equals x minus 1 cubed plus 5. So then we minus 5 from each side. And cube root. The cube root of a negative is a negative. The cube root of a positive is a positive. So while we don't know what the number really is, it is the negative cube root of 5 plus 1. And there is only one x-intercept for a point of inflection graph. So then I can do a really rough sketch. So point of inflection 1, 5. Y-intercept is 4. And so then my x-intercept is going to be somewhere there. They are harder to draw. They're a bit yucky to draw. But we try our best. Oh, that should be a 5, not a 3. That's 4. And that is 1, 5. So always remember to plot those points and actually label them. Labeling the points is important to show that you know where they are. So here's another one. So once again, the transformations. Well, for this one we have translated 2 units left, dilated by a factor of 8 in the y direction and translated 1 unit down. Okay, so now my transformations. Easiest thing to get from these graphs, point of inflection. We just pull it straight from the equation. So, -2, -1, easy. Y-intercept. Well, that's when x equals 0, so we've got y equals 8, 2 cubed minus 1. So 2 cubed is 8, 8 times 8 is 64, 64 minus 1 is 63. So there's our y-intercept. Then x-intercepts. So once again, we just sub in y equals 0, and then we rearrange our equation. So we're going to add 1 to both sides, then divide both sides by 8. Then we're going to cube root both of them. So cube root of 1 is 1, cube root of 8 is 2, and then we're going to take 2. So we get -3 on 2 equals x. So once again, there is only one x-intercept for a point of inflection graph. Then we can graph it. Y, x. So we've got -2, -1, -3 on 2, 64. Whoop, that was badly graphed, but you get the gist. -3 on 2, and -2, -1. So, that's all we have to do to graph a point of inflection. Pretty straightforward. Find me the point of inflection straight from the graph. Find me the y-intercept by subbing in x equals 0. Find me the x-intercept by subbing in y equals 0. And then rearranging. Don't worry about expanding. Easy. Those questions are 7E, page 269, questions 1 and 2.